I'm RAASHID Ahmed meeting you all again on Lankan Mentor. Today we'll be discussing about the third chapter of Grade-10 ICT, Data Representation Methods in the Computer System. So before we move on to the lesson, I recommend you all to take your textbooks close to you so that you can look at the examples when I refer them. And if you don't have the textbook, you can download the chapter number 3 from the link given in the description. Right, let's move on to the lesson. Okay, wonder why I drew this? I'll tell you later. Now, before we go on to data representation methods, we have to look into what and how the data is stored in electronic devices or in the computers. Right? Now, take any computer or any electronic device. These devices, they need electricity to work, which means current. They need current to work. Now, take a refrigerator in your home or a television, right? Even these things run in electricity. These are electronic devices. Now, even that is a computer. Your TV, your television is a computer. It is a special purpose computer, we call it. So that computer is using electricity, right? Now you might have seen this button. What is this? Power button, right? We call it the power button. Why do we call it the power button? Because we have seen it everywhere, right? That is the power button. So the meaning of this is binary 1 and binary 0. Can you see that? This is 1 and this is 0. Binary 1 and binary 0, which means current on and current off. Simply that is the idea, right? So now every electronic device has this symbol. Why? Because they use electricity, which means we represent electricity as 1 or 0. 1 means there is electricity, 0 means there is no electricity, right? So that is what this symbol also denotes. Okay, now binary, we say binary is the language of the computer. Why do we say so? Because computers cannot think. Computers do not think. They work in electricity. They work with the commands that we give them. They work with the instructions that people program inside them, right? Whatever the commands that we give, computer will do. So computer cannot think. So computer knows only electricity. If there is electricity, computer will work. If there is no electricity, computer won't work. Simple theory, right? So now, in every electronic device, now I mentioned TV, fridge, your oven, right, whatever, any electronic device, your smartphones. This is the basic concept. All the data, every command, everything is given through 0 or 1, which means current on, current off, on and off. So now, we as humans, we know a lot of languages. Now take English for example. English has 26 alphabets. There are 26 alphabets, A, B, C, D, E, to X, Y, Z. So this alphabet is the basic thing. After that we create words through them. So we can understand these words and everything. So just like that, computers can understand ones and zeros. Computers can understand ones and zeros. Okay? Right. So this is the idea. Every electronic device stores or uses or transfers data using current, which means 1 and 0. So 1 and 0 means we call it binary. 1 and 0 is binary. So that is why binary is called as the language of a computer. Remember that. Binary is called as the language of a computer. Right. Okay. Now that you have the idea, we'll go on to number systems. Okay, number systems. Number systems. What is that? So what is a system? System means something that is in order. So we know, as I told you before, the alphabet we know, and numbers also, we know numbers also. So why do we use alphabets? To create words so that we can speak, so that we can understand others, right? So that we can converse with others. So that is words. Numbers, why do we use numbers? To show some value. Now let's say I need 500 rupees to watch a movie in a cinema, right? Or else I need 300 rupees to buy a burger, something. That is a number, right? 300, 500. Or let's say Colombo and Kandy is around 105 kilometers apart from each other. Now what is this? 105 kilometers. It is a number. It is a value we give. So numbers, they have some value. To show some value, we use numbers. So something like that. And there are certain things also that we cannot tell in numbers. Now, let's say I'm happy, right? I cannot say I'm 6 happy, right? I'm 8 happy, I'm 10 happy. You don't say that, right? So we don't use numbers for that. But there are things that we can use numbers for. We call them quantifying data, right? So these things that we can use numbers to show values. Now we use decimal numbers in our day-to-day life. Now what is a decimal number? I'll just write, okay, 375. See, this is 375. So what is this 375? I just wrote a number. So this number represents some value. Now let's say I'm saying I have 375 chocolates. Now great, right? So 375 chocolates, and I'm going to eat it alone. Now you're getting angry. Okay, so 375 chocolates means there is a meaning. You can imagine, okay, what is a chocolate? Okay, it is nothing big. 375 chit chat chocolates, so the small ones. So now your battery gone down. Okay, excitement is a bit less. This value, now you can imagine, okay, 375 chit chat chocolates. So it will be like something like in a large shopping bag. It would fit 350 chit chat chocolates. So just like that, whatever that we use in our day-to-day life, right? Numbers, they are decimal numbers. Now decimal means you don't have to confuse like this. Decimal means not this. This part, you call it the decimal point, no, not this, right? This is not what I'm saying as decimal number. Okay, this is different. What I'm saying is decimal number system means it is the numbers that we use in our day-to-day life, usually, whatever the number you are using, between 0 and 9. Okay. Now, we'll discuss about the number systems. We have 4 kinds of number systems. One, decimal, binary, octal, and finally you have hexadecimal. So we'll look at each and every one of these in deep, right? So we'll start with decimal number systems. Okay, decimal number systems. Decimal number in the sense, as I told you earlier, whatever the number that we use regularly, right? Now for each and every number system you have, there is two things that you have to remember. It's base value, base, and the digits used. Okay, so the base is 10 for decimal, and the digits used is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Comes up to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Which means altogether it is 10. Including 0, it is 10 numbers. You have 10 different numbers. That is why it is base 10. You have 10 different values. You see? Altogether, including 0. Right? Okay. Now this base 10 can be explained to you practically. Now just take an example. Let's say I'm writing 4050 and 375 minus. Now I'm going to do a subtraction sum here. Okay, as usual, 5 cannot be subtracted from 0. So what do? You borrow 1 from this side. Now when you borrow 1 from this side, how much comes to the right side? 10. When you borrow 1 from this side, 10 comes over here. That is why 10 minus 5 is 5. How did 10 come there? Because of this. Because the base is 10. Therefore, for each and every part, 10 comes up. Okay. Now here we have 4, right? Now 1 is gone and then we have 4 here. So 4 minus 7 is not possible. So you again borrow 1 from here. There is nothing here, again here. So 1 from here means it comes out as 10. So from 10 you are borrowing 1. So again it comes out as 10. So 10 and 4 is 14. So 14 minus 7 is 7. Right. Here we have 9 now. So 9 minus 3 is 6 and 3. So did you understand? When we are borrowing from this side, we take 10 digits. That is because the base is 10. Right? Now I'll do an addition for you. Let's say I'm adding something, 5149. Right? Adding by 2043. You say just a number. Adding. Okay, 9 plus 3, how much? 9 plus 3 is 12. So you are adding 1 here. What is that 1? 10, right? When 10 fills up, you put it to the other side. See, you see? So 144 is 9. Right? So again, put there and then 1 and 7. Okay. So in this addition, you have the clarity. What is the clarity? 9 plus 3 is 12. So you write the 2 here and put 1 over here. What is that 1? 10. Right? When it becomes 10, you put that 1 over here. That is because base is 10. If you want some more examples, I could say like this. Let's say, take the abacus. 4. Right, now this is ones, this is tens, this is hundreds, this is thousands. Let's say, right? So I'm marking some numbers. This is 1, 2, and 3. There is 3 pebbles there, and 1 over here, and 1 over here. So what is this? We have 1000, and we have 110, and we have 3 ones. So it is 3. So 113. Sorry, 1013. It is 1013. Right. So this is just a number, a decimal number. Now, even in the abacus, see, we separate it as ones, tens, hundreds, thousands, goes on. Right now, in other words, this can be written like this: 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3. The power increases. Right? So what is 10 to the power 1? Any number to the power 0 is 1. Remember that. Now if a to the power 0, it is 45 to the power 0. Say is 45 to the power 0, and 1000 to the power 0. Everything is equal to 1. Any number to the power 0 is 1. Remember that. Okay. Now 10 to the power 0 means 1 here. 10 to the power 1 means 10. So it is here. 10 to the power 2 means 10 into 10. So 100. 10 to the power 3 means 10 into 10 into 10. 3 times. So if you multiply it, you get 1000. So just like that, 1, 10, 100, 1000. That is how the places come. If I just write a number, let's say it is 3244. Now this is the ones place, tens place, hundreds place, thousands place. Right? So this is how we write decimal numbers. But decimal numbers, we don't care about these things. Why? Because we are used to it. Now what matters is how we are going to write the other number systems: binary, octal, and hexadecimal. Right? Okay, now as you have this idea, we'll move on to binary number systems. Right, now in binary number systems, as we discussed earlier, binary is the language of the computer. Now we use only ones and zeros to represent binary. So binary will have the base as 2, which means the bits used are 0 and 1. That's all. 1, 2, that is 2. There are 2 digits, so we that's 2. But you see, I have written bits here. Bit. What is a bit? Bit means binary digit. I see here. Binary digit. So it is like this. Take the B from here and IT from here, put it together. Bit. That's how binary digits are called. Binary digits are called bits. Remember that. Okay? Now, I'll just write a binary number. Yeah. Let's say 1000, 10010 is 2. Okay? Now, this is a bit, this is a bit, bit. So this is a 5-bit number. This is a 5-bit number. This is a 5-bit number. Why? There are 5 digits. Okay, 5 binary digits. So we call it a 5-bit number. Okay? Right. Now with binary, you have a lot of conversions. There's a lot of conversions you have to learn. Now we'll start with decimals, right? Now earlier we discussed some decimal values. Now I'll just write a random decimal number, just a random decimal number, 45. This is a decimal number, okay? So now if we have to convert this to binary, we have to divide this by 2. Why 2? Why do we have to divide by 2? Because the base is 2. As the base is 2, we have to divide this number by 2 to change it to binary, right? We'll see how the division is done. Okay, now you can start with converting decimal to binary. Decimal to binary, right? So we'll start with 45. Okay, 45 is equal to something. We'll find out. You write 45. Okay, you divide it by 2. So how many 2s are there in 45? 22 comes over here. So 2 into 22, 44. So 1 remainder. Put that remainder here, right? Here. Okay. After that, again you divide it by 2. How many 2s are there in 22? 11. So, are there any remainders? 2 into 11, 22. No remainder, which means 0. You have to put this up. You have to put whether there is a remainder or not. If there is a remainder, you have to put it. No remainder, 0. Okay. Again you are dividing. How many 2s are there in 11? 5. So 2 5s are 10, which means from 11 minus 10, you have 1 remainder. So put that 1. Right? Again, how many 2s are there in 5? 2. 2 2s are 4. So 4 minus 5, sorry, 5 minus 4 is 1. So you have 1 remainder. Again, how many 2s are there in 2? 1. 1 into 2, 2. So no remainder. You have to stop here. When you get 1 over here, you can stop. Right? Don't go beyond this. Then you might confuse it. Stop here when you get 1 at last. Right? Okay. Now what we do is, we write the number. We write the number like this. Starting from below. Okay. It's like this. 1 0 1 1 0 1. 1 0 1 1 0 1. Base 2. This is very important. Now base 2 is very important, because if you just write a number, if you just write like this is a decimal number. Why? No base. No base means it is decimal number. We consider it is a decimal number without a base, right? So you should write the base if it is a different number system. Now binary is a different number system. Decimal is different. So you have to put the base, or else no marks, right? Don't forget the base. So 1 0 1 1 0 1, base 2. Okay, right. So this is how you convert a decimal number to binary. Okay, right. Now we'll go to binary to decimal. Now let's say you have a binary number. You have to find the decimal value of that number. Okay, we'll find out. Okay, I have written a binary number 11001 base 2. So it is a binary number, right? So we are going to change it into a decimal number. You are going to find the decimal value of this binary number. Okay, Now first, we have to do the abacus thing. Can you remember? Now we have to put these things into small parts like this. Now if we have 1, 1, 0, 0, 1, right, the same number I have written down. You can write like this: 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. Right? So how much? 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3, 8, 2 to the power 4, 16. Right? You just multiply it by 2 over here. So 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4196, 8192. It goes on like that. Right? So if you have to find these values, right? See, 1, 2, 4, 8, 16. We have only 5 bits. Okay. Now there is 1 over here. 1 means here is also 1. So 1 into 1 plus 0 into 2. 0 into 2 plus 0 into 4. 0 into 4 plus 1 into 8. Here 1 into 8. 1 into 8 plus 1 into 16. 1 into 16. So you have 1 into 1 is 1, 0 into 2 is 0, plus 0 into 4 is 0, plus 1 into 8 is 8, plus 1 into 16 is 16. Right? Now you just have to add the numbers. 16 plus 8, 24, plus 1, 25. So that is your decimal value. The decimal value of this binary number is 25. Right? So now I wrote the 0 values also. You can omit the 0 values if you want. Right? We only need ones because 0 is nothing. So if you multiply it by 0, it will be 0. So you can just skip the 0 part also. Right? Like this. You can only write like this also. Like 1 into 1 is 1, and we only look at the ones. 1 into 8 plus 1 into 16. Like this. So both are correct. Both methods are correct. You can choose whatever is easy for you. Right? So that is the example for converting binary numbers to decimal values. Right? Okay. Now next we'll move on to the next number system, octal number systems. Okay, for octal we have base 8, which means again we go from 0, 1, 2, 3, 4, 5, 6, 7. Not 8, you don't have 8. Why? Because including 0, totally we have 8 digits. That is why it is base 8. So from 0 to 7, the maximum number in octal is 7. Right? Okay. Now, again, like the previous number system, like binary, we'll convert a decimal number into octal number system. Right? Decimal to octal. Right? I'll just choose a number. Let's say 75. 75 we are going to change into octal, right? So when you are changing a decimal number to octal, you have to again divide it by, not multiplication, dividing. When you are changing from decimal to octal, then you have to divide it by 8. From decimal to octal means division. Octal to decimal means that's a different process. Okay. Right, now we have 75 divided by 8. Right, what is this 8? The base. Okay. So in 75, how many 8s do we have? I think 9. Yeah. So we have 9. So 9 8s are 72. So then you have how much? 3 remainder. So then you get 3. The remainder. That's all. Now again you can divide. How many 8s are there in 9? 1. So in 1 and 1 8s are 8. So minus 9 is. So 1 1 3. That is how we go. Again from here. 1 1 3. Base 8. Base 8. Shouldn't forget that. Base 8 is very important. Here. Okay, right. So this is how you convert. It is easy, very easy step. Alright, this is very easy. Decimal to octal, you are just dividing it by the base. Okay. Now we'll go to octal to decimal. We'll change an octal number to decimal number. Okay, 237 base 8. 237 base 8. We are going to change it to decimal value. Right? We're going to find the decimal value of 237 octal. Right? The octal value. Right now, again, we go with the abacus method. How? We divide it into 3 units, like 8 to the power 0, 8 to the power 1, 8 to the power 2, right? So we have, why have you put 8 here? Base, right? Base 8 over here. So 8 to the power 0 is 1, 8 to the power 1 is 8, 8 to the power 2 is 64. Do not write 16. 16 is wrong. 8 to the power 2 means 8 multiplied by 8. Many students make this mistake. Don't write 16. It is 64. 64, right? 8 to the power 2 means 8 multiplied by 8. 8 into 8. 64. Okay, right. Now we know the values. We have 7 for 1. So 7 into 1 plus 3 into 8 2 into 64. 2 into 64. Right. So then you have 7 into 1, 7 plus 3 into 8, 24 plus 2 into 64, 128. Okay, right. Now we have to add these things. The answer is 159. Right, so this is the decimal value of octal 237 base 8. Right, now you don't need these things. Okay, this is your answer. Okay, the previous things was the method, right? You can write it anywhere else, or even in your answer script is okay, right? Even if you write those things here, no problem. But this is the answer. This is the answer, right? If you are doing such a question in part 2, then you need the steps. you need to show the steps how you got it. So when you are converting octal to decimal, this is how you do it, right? You find the values. Okay. Now if you know the values, you can write like this: 1, 8, 64, just like that. You can keep writing, no problem. Okay. Right. Now I hope you have understood changing octal to decimal and decimal to octal, right? So this is the octal number system. Okay. Now we'll move on to the other one. Finally, hexadecimal number system. Okay, so for hexadecimal we have base 16. Base is 16 and the digits used are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we have 10, right? So you can't write 10 like this. Like any other numbers, you don't write 10 as a whole number. Instead of 10, we start with A. So we put A here, right? This is 10. B 11, C 12, D 13, E 14, F 15. So including 0, altogether we have 16 digits. That is the base 16, right? So A means 10, A is 10, B is 11, C is 12, D is 13, E 14, F 15. Don't write these numbers 10, 11, 12, don't write. A, B, C, D, E, just like that. Okay, right. Now we'll go for converting. Okay, we'll convert a decimal number, decimal to hexadecimal. Okay, now I have written 340 as the decimal number. Now we are going to convert 340 into hexadecimal value, right? Now let's see how it is done. You divide 340 by base 16 to convert it from decimal to hexadecimal. So 340, you divide it by 16. How many 16s are there in 340? It's around 21, right? So it is 21. So 21 16s are 336. 21 into 16 is 336. So 340 minus 336, 4 balance, right? Again 21 by 16. How many 16s are there in 21? 1. Okay, 1 into 16, 16. So 21 minus 16 is 5. Okay, so again you are going from this side, so it is 154. Base 16. You have to put the base. For any other number system than decimal, if it is not decimal, then you have to put the base. Right? So this is 16. This has no base, which means it is decimal. Right? So 154 base 16. Right? Okay. So this is how you convert a decimal number into hexadecimal value. Right? Okay. Now we'll go to hexadecimal conversion to decimal. Right? We'll convert a hexadecimal number to decimal value. Now I have written a random number 235 base 16. So we are going to convert this hexadecimal number to decimal value, right? So again the abacus thing, right? So we have to go with 16 to the power 0, 16 to the power 1 and 16 to the power 2. So 16 to the power 0 is 1. 16 to the power 1 is 16. 16 to the power 2 means 16 multiplied by 16. 16 into 16, which is 256. Okay, right. Now we have the values 5 into 1 plus 3 into 16 and 2 into 256. 2 into 256. Right? So you have to find the answer now by multiplication. 5 plus 3 into 16, 48, plus 2 into 256 is 512. So you add the answer, you get 565. 565. So now we don't need this. Okay. So the decimal value of 235 base 16 is 565, right? So this is how you do the conversions. The conversions are very easy, right? The only thing is you need to practice more. When you do a lot of questions, then you will get the idea. Okay? When you are remember this. When you are converting from decimal to another number system, right? From decimal to something else, you have to divide by their base, right? From decimal to some other thing, you have to divide by their base. If you are converting something else to decimal, if you are converting some other number system to decimal, you have to do the abacus method, right? Multiplying and adding this thing, this method. Okay. So other than that, it is very easy. Number systems is easy, right? Okay. So we have learned all the 4 number systems that you need to know, and now we have 2 more other conversions to look into. That is, when you are converting from hexadecimal to binary, binary to hexadecimal, and octal to binary, binary to octal. We have these conversions. Before we go into those conversions, I'll write some numbers, right, to clarify. Okay, now let's say this is 2045 base 8. Okay, now we have different 8 numbers, right? I'm going to tell you which numbers are valid. Okay, valid means correct. Okay, 1011 base 2. Now is this number correct? Yes. Why? It is a binary number with base 2. So this is a binary number. Why? The base is 2 and there are only ones and zeros in the number. Okay, so this is okay. 2045 base 8. Is that number correct? Base 8, 2045. So maximum it can come up to 8. 0, 1, 2, 3, 4, 5, 6, 7 numbers are there in base 8. So this is also possible, right? So base 8, then this is an octal number. That is also okay. 769 base 8. What is wrong here? 769. 9 is not there in octal number system. You see, this is octal, base 8. If it is base 8, there is no 9 in base 8. How much is there in base 8? From 0 to 7. 7 is the largest number in base 8. So 9 cannot come. So this is wrong, right? And 11001. What is this number? Is it binary? No. It is a decimal number. If it is a decimal number, yes, it is correct. Why is it a decimal number? No base, right? No base, so it is a decimal number. So it is correct. 4052 base 2. Base 2 means you only have ones and zeros. So 4 and 5 cannot come, right? So again, this is wrong. And 201 base 8, is it possible? 210, everything is there in base 8. So it is correct. 455, if it doesn't have any base, what is it? Decimal, right? So decimal means it is correct. Now we missed this thing. 53A. A, where does it come into? Hexadecimal. So the base is 16A, right? That is also valid. So try to understand the difference, why these things are wrong and why this is not a binary number. This is not a binary number. Why? Because the base is not mentioned there. Okay, right. So now we'll move on to conversions from hexadecimal to binary and octal to binary and the vice versa. Okay. Okay, we'll start with binary to hexadecimal. Right now, let's say I'll write a random binary number 1011010001 base 2. Right now, this is a binary number. So, when you are converting binary to hexadecimal, it is very easy, right? You know, when you are converting binary to hexadecimal, now hexadecimal digits, see, if you have 4 bits, then it is equal to 15. How does it become 15? So see, this is 1, 2, 4, 8. So 1 into 1, 1 plus 2 plus 4 plus 8. So 1 plus 2 plus 4 plus 8 is 15. So in hexadecimal, the largest number f is 15. So you only need 4 bits, 4 binary digits to represent any hexadecimal number. Right? You only need 4 bits to represent any hexadecimal number. So now this is the method. You have to look at the number, right? From right side, you have to count 4 numbers. 1, 2, 3, 4. Okay, put it across there. Again, 1, 2, 3, 4. 1, that is remaining. Okay. What you have to do is, you have to find the value of each of these numbers. How? Now let's take 1001, this part. So it is 1, 2, 4, 8. 1 and 8, it is 9. So it is 9, right? And again 0, 1, 1, 0. 0, 1, 1, 0. Okay, so how are you going to write? 1, 2, 4, 8. The Pascal abacus method, right? So now 1, which is 2 and 4. So 2 plus 4 is 6. Here, 2 and 4. See, 4 plus 2, which is 6. Here, okay. And again, only 1 is remained. If it is 1, then it is 1. There is nothing, then it is 1. So this part is 1. 1, 6, 9. Base 16. Easy, right? It's very easy. See, you divide it by 4 parts, right? You count 4 numbers, cross, 4 numbers, cross. Then find the values, write the number. Okay, So for hexadecimal, you divide it by 4. For octal, you divide it by 3 numbers. Okay. For hexadecimal, it is 4. Right. Same thing you can do in the opposite way also. Now, if you are converting hexadecimal to binary, again you can do the same thing but opposite. How? 169 base 16. Okay, so you are writing 169 separately. How? You find the binary value of 9 first. 9 divided by 2 is 4, 1 remainder. 4 divided by 2 is 2, 0 remainder, 1, 0 remainder. Right? Now you see 1, 0, 0, 1. You can write 1, 0, 0, 1. Okay? Right. And 6. Find the binary of 6. 6 divided by 2 is 3, no remainder. Divided by 3 is 1 and 1 remainder. So 110. 110 is only 3 bits. We have to write it in 4 bits. Right? When you are converting hexadecimal to binary, in this method you have to write in 4 bits. So 110 means 110. To make it 4 bits, you put a 0 in front. Right? So 0, 110. 0, 1, 1, 0. Right? And finally 1. 1 means 0, 0, 0, 1. That is the binary. So 0, 0, 0, 1. You don't have to put the 0 also because this is the last number. Right? So binary. This is how you convert from hexadecimal to binary. This is an easy way. Okay? And it is the same method that we use for octal also. From binary to octal and octal to binary, same method. We'll try that. Okay, so when we are converting binary to octal, I'll just write a random number. Right, base 2. Okay, it's a random number. Now again, for octal, I told you, when we are converting from binary to octal, you have to divide by 3 numbers. Why is that? Because you see, in octal number systems, you have digits from 0 to 7. So 7 is the largest digit in octal number system. So the binary of 7 is 111 base 2. 7, which means this is 1, 2, 4. So 1 plus 2 plus 4 is 7. Right? So maximum number in octal number system is 7. So you only need 3 bits to represent any octal number using binary. Right? You only need 3 bits. So you divide them by 3 parts. This is the method, right? Binary to octal, you divide them by 3 numbers. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. So now, again you do the same thing. 0, 0, 1, base 2. So you find the value. 1, 2, 4. What is the value? 1. Right? So you write 1 and again 1, 1, 1, 1, 1, 1 base 2. So 1, 2, 4. 4 plus 2 plus 1. Here. That is 7. So you put 7 here. And 1, 0, 0. Again 1, 0, 0 base 2. So it comes out as 1, 2, 4, you only have 4 here. So 4, and see, this is 4, this is 7, this is 1. So it is 471 base 8. This is how you convert a binary number to octal easily, right? So again, it is the vice versa for octal to binary, right? We'll look into that. Octal to binary. Alright, in there you have 471 base 8. So now you have to find the binary value for each and every number. For 1, what is it? 1 divided by 2 is nothing. So it is just 1. So then 1 you can't just write in a single number. You have to write in 3 numbers because it is octal, right? So 0, 0, 1. 0, 0, 1. 7 you have to find the binary. 2 is 3 balance, and 1 and 1 balance. So it is 1, 1, 1. Again 1, 1, 1. Right? And 4, find the binary of 4. Divide by 2, so no remainder. 2 again 1 and no remainder. So 1, 0, 0. 1, 0, 0. Base 2. So you see 471 octal can be written like this in binary very quickly. Right? It is easy. Okay. So now this is all with the conversions with number systems. I hope you might have gotten an idea on what these number systems do and how these are calculated. So these number systems, I'm saying again, they are for giving a value. So binary is a alphabet, is like a number system that computers can understand. Now we can understand decimal numbers. We can understand alphabets, A, B, C, D. Just like that, computers can understand binary. Octal, hexadecimal are for different purposes. So just like that, these number systems are used for different kinds of devices. Okay, right. So that is with the number systems, and if you encounter with any doubts, just drop me a message, I can help you. And today we have to wind up with this, so we'll be discussing about coding systems in our next video. So till then, do your calculations, do some questions using these conversions so that you can refresh your ideas about the conversions. Until then, please support this channel by sharing and subscribing. Thank you.